In this video, we're asked to find the 4/4 roots of -16. So if we again go back to our nth roots theorem, the roots are the fourth roots in this case would be z0, 1, 2, 3, where again it's the nth root of the magnitude of our complex number, CIS theta over n plus 360 over n k. So here again, we're finding the fourth roots of -16. So the first thing we do is we take the number -16 and we graph it on the real imaginary plane. So of course it's sitting over there. That would be a real number with a magnitude of 16, and the angle there would be 180 degrees or pi. So we could write -16 down as 16 CIS 180 degrees. And so then we want to do the fourth roots. So we would again, ZK is the fourth root of our number. So the fourth root of our magnitude, fourth root of 16. And in CIS, we take our angle, it's fourth root, so we divide by 4. And then plus 360 divided by 4 times k. That's our formula. And of course, we can work those out then. Z0, oops, go back one here, would be 2 CIS 45 degrees because k is 0. Now again, if you're putting this in exponential form, the angle has to be in radians, so that would be 2 I pi over 4, e to the I pi over 4, or pi over 4i. You can write it either way. And so, again, it has to be in radians for these exponential relationships. And that just goes back to something from calculus where this relationship between CIS, cosine I sine, and e to the I theta. So again, that's if in the homework you're asked about the exponential format, which I'm usually not worried about. I'm just more interested in computing these things. So as we continue on here, we would say cosine 2 times cosine of 45. Cosine of 45 is square root of 2 over 2 times 2, so it would be square root of 2. And of course, sine of 45 would also be square root of 2 over 2. When we multiply by 2, we get I square root of 2. If you took that thing and raised it to the fourth power, you will get -16. We can see that really easily in the trig form. Raising it to the fourth power in the trig form would be 45 times 4, which would be 180. And of course, 2 to the fourth would be 16. 16 would be CIS 180, of course, would be back to -16. But if you did all the messy algebra of square root of 2 plus I square root of 2 times itself 4 times, multiply it out, it would eventually simplify to be -16. And then we just continue this process, computing Z1. 2 CIS 135, right? Because 360 divided by 4 is 90. The fourth roots are all going to be equally spaced by 90 degrees. So the first one was 45. So the next one will be 90 degrees more. And we compute that. Cosine of 135 is negative square root of 2 over 2. So, of course, we get negative square root of 2. Sine of 135 with a reference angle of 45 is square root of 2 over 2 in the second quadrant. So we get times 2 I square root of 2. And again, Z2 would be 2 CIS 225. Which when we work that out would be negative square root of 2 minus I square root of 2. And then finally, Z3 would be 2 CIS 315 degrees, which would be square root of 2 minus I square root of 2. So, of course, the next one we got, if we add another 90 degrees on, would be 2 CIS 440 5 degrees. 405, though, would be coterminal with 45. So we would be back around again. So we have our 4 distinct fourth roots of negative 16. Boy, you thought it was bad a long time ago when you learned how to do square root of negative 16, and you got that 4i or negative 4i. Well, now you can see it's a lot more work. That's why you stopped at square roots. You never went on to fourth roots. All right, we have all these big messy things. These 4 things are the fourth roots of negative 16. And then the final thing I wanted to show you here was the picture. Square root of 2 plus square root of 2i, negative square root of 2 minus, or plus square root of 2i, negative square root of 2 minus square root of 2i, and finally square root of 2 minus square root of 2i. There's my 4 roots on a circle of radius 2, which is the magnitude of the fourth root of 16. And of course, they're all spaced by 90 degrees. So these are all right angles in between each of these. Okay, and so those are our fourth roots of negative 16. So hopefully these examples here will help you as you start to work through computing fourth roots, or any roots, fourth roots, fifth roots, sixth roots of complex numbers.